Welcome you all, my dear students. We'll start. Irshad, am I audible?
Yes, sir, audible.
Okay. Okay. In last class, we discussed about soil mechanics. 1 minute. Okay, soil mechanics, and today we are about to discuss consolidation, consolidation of soils, principles of consolidation, degree of consolidation, pre-consolidation pressure, normally consolidation, E-log curve, computation of ultimate settlement. This much. Okay, we'll be covering the blue underline topics. Right? Now we'll understand what is consolidation. Okay, in the first class we have already explained you the three-phase system. Okay, what is the three-phase system? It will be having solids, and it will be having water and air. Okay, let us consider this is volume of air, volume of water, and volume of solids. Before understanding consolidation theory, we have to understand what is exactly the compressibility of the soil. Compressibility, correct? Here compressibility means, here you can see the one word is compression and another word is ability. Means whether the soil is compressible or not. This question we have to answer, whether the soil is compressible or not. Then how you define the soil is compressible or not? You know, compression means what? If any change in the volume occurs, then that I can consider it as a compression. Then ability means the soil is able to compress. Then what is the reason that the soil will get compressed? Here we have a three phases. The one is a solid, and the second one is a water, and the third one is the air. Which phase will compress so that the entire soil will be compressed? That we need to assess. Right? Let us consider, I will put a load here. The load, whatever the load it might be, the compressor, this static load or dynamic load or compaction, vibration, whatever it is, this load I am applying, and because of this the change in volume occurs or not, that we have to understand. What do you say? Change in volume occurs, whether the soil is compressible or not. What do you say? Anyone?
Compressible.
Yes, compressible means you are agreeing that when we apply load, then volume will change, volume will decrease. Okay, I will consider, if you increase the load, then volume will decrease. Okay, volume decrement will occur in which of these phases? Means I want four reasons. One, two, three, four. I want four reasons for decreasing the volume. Can anyone list these four reasons? I will give one reason. The first reason is air compresses. Air compresses means, let us consider this air is there, no, this volume. When I apply this load, then small amount of the air will get compressed. Because of that, the total volume is reduced. Now see the red line, the total volume is reduced, means totally volume is reduced. Volume is reduced means compression happened. Then I got first reason, that is air compressed, that's why the compressibility is there in the soil. Then can you give other reasons why that volume will get decreases? There are four reasons. Can you name other reasons? No? Okay, I will give the second reason. The second reason is air escapes.
Whites, sir, whites.
What happens to whites?
Sir, whites will be.
Hmm. Okay, voids will decrease. What you want to say is a voids will decrease. No? Voids means air and water. No, these two together it is called as a voids. Now,
Yes.
particularly, I have answered two of these four. That is air compresses and air escapes. Means again this is a void only. Right? So the third reason
Yes.
will be what? What is your comment on water? Water compresses or water escapes? Which one will
Water
consider?
escapes, sir.
Water compression will consider or not?
Escape, sir.
What about water compression? Will water compress or only will escape? Okay. Here, water will never compress because in fluid mechanics we have studied that water is incompressible. Water is incompressible. But in fluid mechanics we have studied air is compressible. No? Air is compressible. That's why I got a two options in air media. The first option is air compression and the second option is air escape. The third one is water. When I come to the water, then water compression is not possible. Therefore, water escapes. Escapes word is not better for this water. Therefore, I will use expel. No? Water expels. Then water phase is over. Is there any change that happens in the solid phase so that I can give the fourth reason for compression? Is there anything that happens in the solid phase so that the volume compression will occur? No idea? Okay. Now here you have to think like this. The solids, we assume that they are incompressible. The solids are incompressible and solids will not escape. If solids are escaping means that is a wrong concept because we are studying the soil means major proportion is the solids, therefore solid escape is wrong one. Then the next one is expulsion is also not there, but still there happens one process in the solids that is called as a rearrangement of the particles. Rearrangement of particles. When rearrangement of particles takes place, then I can say little amount of solids, that volume will be reduced. Means I got here four reasons to say the soil is compressible. I got four reasons to say the soil is compressible. Out of these four reasons, I have to evaluate. No, I have to evaluate. Very clearly, I have to evaluate. Look at here. The first two reasons, the first two reasons are considered as initial consolidation. Initial consolidation. See here, one word we got. What is the meaning of initial consolidation? Initial consolidation means air compression and air escapes. Okay, that is initial consolidation. The second reason, whatever that is there here, this second reason is considered as a primary consolidation. Primary consolidation. The third reason, the third set, that is the fourth reason. If I consider this one, this is a secondary consolidation. Secondary consolidation. Now, very interestingly, the soil, whatever that is there on the earth, we can distinguish into two different type of soil. Okay, not coarse grained and fine grained soil. The entire soil can be differentiated into two types. That I will call it as a one is a inorganic soil, and the second one is organic soil. Right? Inorganic soil means most of the soil what we are experiencing or what we are using in the civil engineering, that is your inorganic. You can consider gravel, sand, silt and clay. These all are inorganic soil. But organic soil means we have a peat, and muck. These are all your organic soil. In organic soil only we will be getting the secondary consolidation. Remember this. This is very important question. They may ask you. The secondary consolidation will appear only in organic soil. Secondary consolidation will not appear in inorganic soil. This is very important. You have to note down. Means from this consolidation chapter, I will remove this fourth reason, that is rearrangement of the particle will not happen in the inorganic soil. Therefore, the fourth option I will not study. And if you want to study, this will be in higher studies. For diploma level or B level, the secondary compression or secondary consolidation is not included in the syllabus. Okay. Now we remove the fourth reason. Now coming to the first reason, that is the initial consolidation. Initial consolidation means that will be happening in the compaction chapter. Compaction, what is the meaning of compaction? Reduction of voids. Which type of voids? Reduction of air voids. Reduction of air voids. Therefore, the first two reasons also I am eliminating from the consolidation chapter. That will be studied in the compaction chapter. Now, only reason that is left with the compressibility, to define compressibility, is the water expulsion. Water expulsion. This is the only reason we got for consolidation. Then this consolidation is called as a primary consolidation. Primary consolidation. Now, only reason is there. No, that's why henceforth, whenever I use a consolidation, the word, whenever I use a consolidation, then you should assume that this is a primary consolidation. Okay, don't ask me that if I say the consolidation means that is a primary consolidation. If I go to the syllabus, you can see the syllabus, the consolidation of soil they have written here, right? They are not interested in initial consolidation and they are not interested in secondary consolidation. Here, consolidation of soil they have written means they are talking about primary consolidation. Then what is the definition of primary consolidation? This is a process of expulsion of water under static load. Under static load. This is very important. The static load we are applying, we are not applying any dynamic load. This is a static load. Static load means what? With respect to time, this load is not changing. Let us consider you put a 10 kg stone on the soil, 10 kg stone on the soil, then the soil is just experiencing the 10 kg, and after one day with the same load, if you come back and see, the soil will be compressed. Soil will be compressed. What happened in the soil? Then water inside will be escaped or expelled. This example you will see when you do Shrikhand. You know, when you do Shrikhand from this curd. You know, or otherwise, do you know the process of making paneer? Do you know the process of making paneer? You will take a milk, then you will put some sour or lemon juice, lemon drops, then this will be spoiled, and this spoiled milk you will put it under a constant load. You will put some load on the spoiled milk. It might be 10 kg stone like something. Then this water will be escaped out. Then only the solid particles will be left inside. That is your paneer. The same process, the paneer process, whatever that is there, that is your consolidation. Expulsion of water from the paneer or expulsion of water from the soil is a process called as consolidation. Do you have any doubt till now? You must understand the four reasons. Out of those four reasons, first two reasons are compaction, the last reason is secondary consolidation, the left out reason is your water expulsion. That is your primary consolidation. Primary consolidation is just a name and we are just giving it as a common name for the consolidation. Okay, this is all about principles behind consolidation and why that consolidation happens, or the initial names of consolidation. Don't think this is a type of consolidation. No, okay, these are not type of consolidation. Types of consolidation are different. These you can call it as a stages of consolidation. Stages of consolidation. Okay, why? Because whenever you do whenever you apply a static load on the soil, the first stage is your initial consolidation. The second stage will be primary consolidation. The third stage will be secondary consolidation. These are the stages, okay, not the types. Right on? Any doubts? Now we will understand consolidation test. Then this chapter will be end. You know? See, I always tell you that this is a very interesting chapter actually, and for competitive exam also this is very interesting, and for gate also interesting, and you go anywhere. Geotechnical means consolidation. Okay, give me the correct reason why water escapes or why water expels. Can you give me the correct reason? This is your solids, and inside this solid water is there. Okay, why water is escaping? The first reason I will give you, because you have applied static load. Second reason, but static load, application of static load is not a correct reason, but consolidation or expulsion of water is happening because of what? This is one reason static load is there. Can you guess the correct reason for expulsion of water? Why water soil is allowing water to escape? Which property is making consolidation? Which property is making this consolidation happening? No idea? Okay. This consolidation is happening because the soil is permeable. Very interesting. The soil is permeable. Right? If the soil is not permeable, then this expulsion of water will not happen. Now, the permeability of clay and permeability in sand, which will be more? Permeability in clay is more or in sand is more?
Sand is more.
Okay.
Sand.
Okay. Okay. If permeability, this escape of this water in sand is quick or clay is quick?
Sand is with
Sand is quick. Can you guess how many minutes it might take to escape? Guess. Just I am asking you to guess. How many minutes or how many hours or how many days? How you can count the time in escape of water in sand? Okay, na? Okay, if you don't know, I will tell you. In sand, it will just we can measure the time is a minutes. It will take only few minutes to expel all the water from the sand. Therefore, the consolidation process will not study for sand. Why? Because it will take just hardly a few minutes, and after that water will be escaped, and you will get whatever the settlement. That settlement is considered as the initial settlement. That is not a consolidation settlement, because before application of the load only the high permeability, and therefore water will escape. But when you come to the clay particles, I already explained in the previous class that clay particles are negatively charged, and water will come and stick on the clay particles like this, and this layer is called as a rigidly held layer, and above this layer will be freely held layer. When I apply some force to this one, the first thing is that freely held layer will be expelled out, but this rigidly held layer will never or require more force to expel it out. More force means what? More time is required to expel this rigidly held layer. Therefore, the clay particles or clay soil will get a lot of time to expel its water. How much lot of time? Okay, that depends on the quantity of the soil also. In experiment, in laboratory, it may take for 90% of expulsion, 90% of expulsion, it may take around 1 month. Okay, but in field to get this 90% of expulsion of water, it may take about 15 years, 20 years, 100 years, depending on the soil and depending on the characteristics. 4 years, sometimes 150 years, you know, it will take for 90% of consolidation. It is taking this much of time, but in the laboratory we may make it very quick in 1 month or 2 months, like that. Understood? That's why It is very important to study this consolidation chapter. Consolidation means primary consolidation. Consolidation means water expulsion. Then consolidation will we are studying in clay particles. Okay, no need to mention which type of soil in consolidation chapter. Consolidation chapter means you should think that it is a soil, clay particles. It is default. Okay, now one more important question I am asking you, that see, this is your three phase diagram. Then this is a water and this is the air. Initial consolidation means when I apply the load to this soil, apply load, static load to this one, then after that these all voids, air voids will be escaped, then you got this much is your soil. Now whether this soil is saturated, question, whether this soil is saturated? Yes, right. This soil is saturated because all air voids are expelled. Means when initial consolidation happens, then soil will reach to 100% consolidation. 100% consolidation. Okay. After initial consolidation, primary consolidation starts. When primary consolidation starts, water starts expelling. Okay, now my very important question is, as the primary consolidation begins, degree of saturation will be option A increases, option B decreases, option C remain constant, option D doesn't depend doesn't depend on degree of saturation. Which option? As the consolidation proceeds, the degree of saturation, what happens to that? No idea? This you have to answer. Very interesting. If you understand this process, then only the entire consolidation chapter will be easier.
So it increases.
Increases. Okay. What about others? Is it correct answer?
So mostly increases.
Increases. Water is escaping from the soil. Degree of saturation I am asking. Water is coming out of the soil, and degree of saturation, what happens to that? Hmm?
Sir, it's a constant, sir.
Constant. How you can prove it? How you can say that it is constant? Reasons?
Sir, degree of saturation does not depend on wide ratio, sir.
Hmm, it is not depending on wide ratio, but I am not talking anything about wide ratio here. Expulsion of water and degree of saturation. Okay, I'll tell you.
Both the volume of water and volume of voids are reducing.
Volume of water and both volume of voids. Okay, volume of water itself is a volume of voids. Correct? Huh? This is, I can consider it as a correct answer. Okay, let us consider this is your solids. Initially, this much of water was there. Now this diagram is saturated. Then when I apply the load, then the diagram will be this much. Sorry. When I apply the load, then the diagram will be like this. Right? What happened to this much? It is expelled. This much of water is expelled, removed. Then this is left. Now what about whether this is saturated or not? This is also saturated. This is also saturated. Even the water is escaped, but still that is saturated. Okay, I will increase further load and I will wait for further days. Then let us consider this is solid and this is your water. Okay, now this much amount of water is escaped. Okay, now what about this one? Whether this is saturated? Yes, this is also saturated. Therefore the consolidation process is going on, but degree of saturation is remains constant, because both whites, this is your whites and this is your water, both are decreasing at a time. Therefore your equation is vw divided by vv, and both are equal in all the cases. Therefore degree of saturation is constant. Okay, means from this we can understand that if you want to study consolidation, which consolidation? If you want to study primary consolidation, then soil must be saturated. Soil must be saturated, or in the laboratory you make soil saturated, then you apply the load, then it will start expelling, then you can study consolidation behavior. Understood? Now we will go ahead with the consolidation experiment. For that I will share the some apparatus used in consolidation. Later we'll come back to the this rough notebook. Now you can see this is a bench type consolidation equipment apparatus. Right now you can see this one. This is very important for us. Here we have one assemble. Inside we will put some water. Then after that we will put this ring. This is called as consolidation ring. This consolidation ring, the top edge is sharpened so that you can press it in the ground and level the top and bottom of soil. Then that soil you can bring it here. Then the arrangement will be something like this. This is your soil, whether it is disturbed or undisturbed soil. Then this is your container, and this assembly we will put it in the big container. This is your big container. In that one we will put, and we will make some arrangement here so that the water will be completely filled. This is your water. From top and bottom water is there. Then above this soil we will make some arrangement. Then we will start applying the loads. How we will apply the loads? This second diagram will explain you. See, this is your consolidation. This apparatus will be set here, and after that this top load will be applied by using this arm. Okay, here you will be putting loads. This is some load, and after that increase the load, after that again increase the load. Like that you are increasing the load. When you apply this load, then the water will start escaping from the water. Then this escape of the water, you cannot measure it because the entire assembly is put in the water bath. That you cannot measure. To measure this one, we will apply one dial gauge here. This dial gauge will measure the decrease in the height of the sample. Decrease in the height of the sample means expulsion of water. Then we will take many readings, and after that we'll study this one. Right? Just go through this equipment. This only I will use it in the further explanation. This consolidation test. Any doubt? Do you have any doubt? Want to ask anything? Okay.
Sir,
Ah.
how much time is required, sir, for take reading?
Okay, here that I will explain. In the laboratory, actually this is all depending on the soil and depending on the static load. Usually time is required is continuously will take for a particular load. 1 day is required, or 1.5 day required, or 6 hours, 8 hours it is required. Like that it may require for 1 month. Means every day 6 hours you are taking a reading. Like that it might be for 15 days, 20 days, 30 days. It's a very huge experiment. Okay, now I will explain you the procedure.
Sir,
Huh.
Sir, the sample clay soil first ಅದು answer.
You have to take clay sample only, because if you take a sand sample, no, then what happens? Consolidation happens in 5 to 10 minutes. Then why to make this much of big chapter and studying this one? No, that's why sand has a high permeable. Therefore, the water escape will be very quick in the sand. That's why consolidation chapter will not study for sand soil. Okay, now. Okay. Now we'll understand the experiment. See here, you always think understanding the experiment itself is understanding this entire chapter. Okay, na? I'm stressing it once again. Understanding the experiment itself is understanding the entire chapter. If you have a very clear grip on the experiment, then you can answer any questions in this chapter. Okay, na? Now we'll understand the experiment. That's why I will spend time on this test. Now let us consider this is your soil sample, and the soil sample is kept in the ring. This is your side wall of the ring. This is kept. Now we will make small arrangement at the bottom. This is small arrangement in the bottom. This is your soil. Okay, na? Then above this soil we will keep one porous stone, so that the water will escape from top, and we'll keep another porous stone in the bottom so that the water can escape from the bottom also. And this assembly we will keep it in the big container, and this entire thing is called as a voidometer. You remember this one, voidometer is the instrument used to determine consolidation, right? Now the entire assembly is kept in the big container, and where the water is filled like this. Okay, now this is enough. Then after that we will apply some load, static load, on this sample. For that I will make an arrangement here. I will make a small arrangement that I will put one steel plate, and above that steel plate I will put one ball ring so that this can distribute load equally. Then I will apply load here. Okay, na? Now very interesting. How much load I have to apply here? Very interesting. The test is started for day 1. This is the first day. Then the tabular column is like this: a time and a displacement. This is the first day table. And day 1, how much load you are applying, you will write it here. The first day I will apply 0.5 kg per centimeter square. This much load I will apply. Where I am applying? Here I am applying 0.5 kg per centimeter square. I already told you that the consolidation process will happen in a static load. Static load means 0.5 kg per centimeter square, that you cannot increase and decrease. Just keep it constant. Okay, then when you keep this constant, then at a 1 minute, first at a 0 minute, just read the displacement, that will be 0, and then you read a reading at 1 minute. Then you will write the displacement, then double the time, read the displacement, double the time, read the displacement, 8 minutes, 16 minutes, 30 minutes, 60 minutes, 120 minutes, like that go on doubling the minutes, 240 minutes, like that you can take it till 1 day, means 1440 minutes. Okay, or you can go beyond also, or you can below this time also, you know, lesser than this time also, you can stop the experiment. Then how you will come to know that we have to stop the experiment? When any two readings are same. Let us consider at this point of time some reading is there, and another point of time also the same reading we have got, means the compression has stopped. Compression has stopped means you can stop the experiment. Right on. This is first day experiment is stopped, but don't remove any sample, and don't disturb this entire assembly. Just you go to the next day. The second day you increase this load. You increase 1 kg per, that load will be 1 kg per centimeter square, means add zero point 0.5 to earlier 0.5, then it will be 1 kg per centimeter square. Then again the same time for 0 minute, 1 minute, 2 minute, 4 minute, 8 minutes, 16 minutes, 30 minutes, like that you go on increasing the time. And again, when two readings will be constant, then you stop the experiment. You stop taking the readings. Then go to the next day. The next day will be your 2 kg per centimeter square. Then the next day will be 4 kg, next 8 kg, next 16 kg, 32 kg, 64 kg, 128 kg per centimeter square. Like that you go on increasing. When you have to stop this one? No, this one increasing, doubling. That load is doubling. But when you have to stop, when you apply some, let us consider 64 kg per centimeter square, when you apply, then the final displacement is something here. And when you double this load as a 128 kg per centimeter square, then also the load is same. Then there is no, you are not observing any change from this point, this table and this table. You are not observing any change, then you can stop this experiment. Okay, now stop taking the readings. How many days are there? Count here. You can see for this experiment only, randomly chosen experiment. First day, second day, third, fourth, fifth, sixth, seventh, eighth, ninth day you have stopped taking the readings. Now remember, ninth day you have applied 128 kg per centimeter square load. Correct? Now after this, remove a load. Removing the load, that will be 1/4 of earlier load. 1/4. 128 divided by 4 will be how much? 32. Then now put 32 kg per centimeter square and remove the rest load. Then the next day you remove this one 1/4. 1/4 means how much? 16, 8. Then 8 kg per centimeter square. Then 1/4. 2 kg per centimeter square. Then 1/4. 0.5 kg per centimeter square. Right? Now you have stopped the experiment. Okay, this is called as a remove, that unloading. No, this I will name it as a loading. This I will consider it as a loading. This is loading. Then this is called as a unloading. Then the experiment is not yet completed. Then after this 0.5 kg, don't disturb the assembly. Start increasing again. That 0.5, that become 1, that become 2, that become 4, 6, 8, 16, 32, 64, 128. No? Now, 128 kg per centimeter square already you have applied in loading case. Then after that, that 128 become zero point 0.5 in unloading case. But this case is called as a reloading. This is called as a reloading. Reloading case, again from 0.5 to 128 has happened. But in reloading, we have to go beyond 128 forcibly. That is 128 to 56. Then 512. Then 1024. 1024, like that you have to go, must and should, you have to go beyond the loading rate. Then you will go there, and after that you will stop the experiment. Now one of you asked me that how many days or how much time it will take the consolidation. Then you can answer me, that is ninth day you have applied 128, and 10th, right? Here 10th day, sorry, this is not 10th, 11, 12, 13. 13th day you came again 0 0.5, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Total 25 days experiment it is, without disturbing any initial conditions. Right? What happened in this 25 days? In this 25 days, we have witnessed loading. Means when we witness this loading, the soil is called as compressed. Then after that, in the second set we have made unloading. When we make this unloading, then the soil will experience expansion. Then when I start reloading, then the soil will experience recompression. Then I can say This is your consolidation test. Okay, why we are doing like this, loading, unloading, reloading? Because we are geotechnical, the feelings of soil. Let us consider this is your ground, ground level, and you want to build a building, 1 story, 2 story, 3 story, 4 story, 5 story, like that. You have built about 10 story building. Then when you build this 10-story building, what this soil is experiencing inside? Now, that is increasing the load, no? Then 1 story load, 2 story load, 3 story load, 4 story load, like that. The load is increasing on this soil. Then suddenly after 100 years, then you will come to know that the building is not stable. Then you will collapse this, collapse, 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 collapse. When you collapse, then again study this point of soil, then the soil is experiencing unloading. Then after this one, after your grandchildren or grandchildren, they are very rich, they will construct a big building on that one. Now this time they will not construct 10-story building, they will construct a 50-story building. They will construct 50-story building, right? Now think of this soil. This soil is experiencing reloading, or this soil is recompressing. This is the process. Then how this soil is behaving inside, that will explain this test. Okay, now this is all about consolidation. This is all about consolidation. Considering these points, I will explain you the type of consolidation. Type of consolidation. To understand this type of consolidation, I will give you three case studies, so that you can understand this very clearly. The first case study is, here there is a one field, khet, wala. There is a one field. On this field only they are growing some vegetables or otherwise some crops. They are growing some crops. Suddenly, this field is converted into non-agricultural land, and after that this field is sold as a plots, 30 by 40, 30 by 40 plots they have made and sold. Now you are building one home on this flat, right? This is one case. Another case is, you have got Taj Mahal, right? This is a Taj Mahal. Okay, Taj Mahal means it is very big structure, very huge structure. Now on suddenly something has happened, therefore Taj Mahal was collapsed. Then after that you have leveled the ground, and this leveled ground, there where Taj Mahal was there, once upon a time in India, Taj Mahal was there. At that time, 1 minute. Okay, once upon a time in India, Taj Mahal was there. Now there is no Taj Mahal, but at at the place of Taj Mahal where it was built, that place also made into 30 by 40 site, and that is sold. Again, that 35-40 site is sold. Then one of you purchased that site and you have constructed a building. Here also one building is there. Here also one building is there. Then what is the difference between this building and this building, or this soil and this soil? This soil and this soil. Okay, if you think of these two conditions, here past pressure sigma past means previous pressure was not there, therefore past pressure is less than the present pressure. Agree? Past pressure is less than the present pressure, and here past pressure is very 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 huge compared to present pressure. Therefore, this condition is considered as over consolidated soil. Consolidated. This is called as over consolidated soil. Why? Because this soil is consolidated. How much consolidated? Over consolidated. Right? Now, the second one is, the first case is, here this is under consolidated soil. Under consolidated soil. Okay, the soil has not experienced any big load. Therefore, this is under consolidated. But here I will give you a third case study. The third case study is something like there was a ground here, and you have earlier there was a home. Earlier there was a home. Because of some reasons, this home is collapsed, or otherwise you just destroyed that home, and after that you again constructed one more home. Then what this soil is experiencing? Then past pressure is equal to present pressure. Then you are experiencing this one. This is called as normally consolidated load, consolidated soil, normally consolidated soil. Right? Normally consolidated, under consolidated, over consolidated. Now tell me, if I ask you and if I give you three cases, three plots, then which one you want to take? Case 1, case 2, case 3, which is best, which is good for civil engineering, or which will give you less failure conditions? Tell me. Hmm?
Because settlements will be lower in that case.
Which one? Which case? Over consolidated or under consolidated?
Over.
Consult.
Over consolidated. Good answer. Over consolidated soil, because that soil is a very experienced soil. It already experienced. वो ऐसा बोलता है ना, मेरे ऊपर एक जमाने में मेरे ऊपर ताजमहल था, है ना? ये 30/40 एक रेजिडेंशियल घर, ये बहुत छोटा है ना? It experiences a very small load. That's why it is very experienced, and the settlement will be less and the failure will be less. That's why over consolidated soil is more preferred. Normal consolidated soil is somewhat good, but when you are doing under consolidated soil, when you are dealing under consolidated soil, then you have to be very, 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 very careful. When a field is converted into a plot, let us consider black cotton soil field is there. That field is converted into NA plot. Then you have got one 30/40 site. Then you want to construct a building. There you have to take care of that field. You have to do all the experiments and worry a lot. But over consolidated, that's it's not that much. Now we have understood the consolidation process and the test consolidation, and why this test is designed in this way also we understood. Now we will go the parameters present in the test readings. Okay, I already told you that in the day one you have time in one column and displacement in another column, right? Displacement. Then what is the displacement? If I put this ring apparatus and the soil sample, then this is called as height of the soil, that I will consider it as a h. Then when I apply a load, there will be small amount of decrease in the height. That decrease in the height I will consider it as a delta h. Then what is this? This is your delta h. Delta h is what? Decrease in the load, sorry, decrease in the height. When this decrease in the height takes place, why this decrease in the height taken place? Because this much amount of water is expelled out. Water is expelled out. This much amount of water is expelled out. That's why you are seeing some decrement in the soil. Understood? From this and area, the top plan area is constant. Therefore, instead of writing this VV equal to E, voids ratio equal to VV divided by VS, may I write it like E equal to HV divided by HS? Yeah, I can write it, because if I multiply area in the top numerator and denominator, then this will convert it into VV by VS only, no? Because area into height is volume. Therefore, area I cancel, then HV by HS, I can write it like this. Means, however, don't worry about much about this experiment, because we are studying for paper 1, how this all HV, HS came, don't worry. By doing this experiment, we will get a White's ratio. By doing this experiment, we will get a White's ratio. Means now I have got one that table here. Time is there, delta H is there, White's ratio is there. This is for a particular day. Per day means what? One particular load P. One particular load P. Then I have many days. Many days means P1, P2, P3, like that many days are there. Means for many days I will be getting E1, E2, E3, like that I will be getting many White's ratios. Then I will draw a graph. Very important terms I will introduce from now. Then I will draw a graph between White's ratio and a load. White's ratio and the load. Right? When I draw this graph, White's ratio versus load, then I will get a graph this way. This is your graph because as a, sorry, this White's ratio will keep here and the load will be here. Okay, load because it is in our hand. No, load is in our hand. White's ratio is not in our hand. Therefore, Y is a yeah, dependent variable and the load is a independent variable. Therefore, this will be decreasing. As you increase the load, then White's ratio is decreasing. Then let us consider this is your maximum decrease and this is your initial White's ratio E naught. And this is ET, White's ratio at any time, or EF, final White's ratio. Then if you take a slope of this curve, the slope at any point, if you take a slope of this curve means what? This angle, that angle means what? This is delta E. Then bottom one is delta sigma. Therefore you will get a ratio of delta E divided by delta sigma. This is nothing but AV. AV means coefficient of compressibility. Write it down. Very interesting. We have got here AV. Any doubt? Here you should have one doubt. No doubt? Okay. The doubt is White's ratio is very small value. You know White's ratio how much it is? It might be earlier it might be 0.75 and later it might be reduced to 0.44. You know this reduction is very small. But the load first day you started with 0.5 kg per centimeter square and at the end of the day you are getting a 256 or 512. See the load variation is very huge. Therefore this is not best fitting graph. This graph is not best fitting. Therefore we will take a semi-log graph. When I take a semi-log graph, then x-axis will be log sigma and the y-axis is White's ratio. There I will draw a curve, then the curve will be like this. Then here, if I take a slope of this one, then this is the delta E and this is a, this you can consider it as a log sigma 2 and this is a log sigma 1. Therefore, you will get a ratio of delta E divided by log of sigma 2 minus sigma 1. Therefore, log sigma 2 divided by log sigma 1. This is nothing but Cc. Cc is compression index. Cc is compression index. Right? Now we will go to strength of material. Strength of material we have studied the bulk modulus. Bulk modulus means what? When you have a three-dimensional forces x and y, z, sigma x, sigma y, sigma z, three-dimensional forces, then there will be volumetric change. That is your volumetric strain will be appearing. Change in volume will appear. Change in volume is appearing means what? The material is compressible material. The compressible material means that is C is called as a compressibility. How this compressibility is defined? This compressibility is defined as 1 by K. Then what is this K? K is a bulk modulus. K is a bulk modulus. Or you can write it a K is something like a sigma divided by volumetric strain. Then sigma by volumetric strain. This one, this much you got. Means in this compressibility is nothing but 1 by K. Then compressibility is nothing but 1 divided by sigma by epsilon V. This you can write it like epsilon V divided by sigma. What is this sigma? Change in pressure, therefore delta sigma. And this, what is this volumetric strain? Volumetric strain is change in volume divided by original volume into delta sigma. This is your C value. C means what? Compressibility. Compressibility. This theory, whatever I explained, this theory is in strength of material and the same mechanics, because this is a soil mechanics. No, the same concept I am bringing it in the geotechnical, but instead of calling C here in geotechnical engineering, we will call it as a MV. Why I don't know, but both are same. Strength of material C, fluid mechanics C, and geotechnical MV, both are same. The formula is delta V divided by V into delta sigma. Right? Okay. Now we know that volume means area into height. This you know. Then delta V means what? Area into delta H. Okay. If I consider these and if I substitute here, then you will get a small derivation here. That derivation tell you that MV is equal to delta H divided by 1 plus E into delta sigma. A small derivation will come here. From that we will assume this one, we will get the equation this one. Then from here, what is this delta H? Delta H is equal to mv into 1 plus E into delta sigma. This equation you can consider. Then what is this delta H? Delta H means what? Go to the diagram. Here, what is this delta H? Can you give a different name to this delta H? Can you give a different name to the delta H? Interesting name. No idea?
So, so change in the height.
Change in height. Delta H means change in height. Can you give some general name? Okay. May I call it as a settlement? Omkar Patil, why you are presenting? Okay. Sorry, no problem. Then, can you call this delta H as a settlement? Yeah, I can call this as a settlement. Then see here, interestingly, I got settlement equation. Settlement is equal to mv into 1 plus E into delta sigma. This is your settlement equation. But to determine settlement, you must know what? You must know MV. You must know MV. Or you can write it something like this also. Here you come here. Where is MV? Here. From this diagram, you can write it like this also. S equal to MV into delta V in sorry delta H. Correct it. Remember that only. Not this one. This one. See here, we already defined Cc equal to delta E divided by log of sigma 2 divided by sigma 1, and we have already defined AV equal to delta E divided by delta sigma, and we have defined mv equal to delta v divided by v into delta sigma. See here, delta sigma is there, here delta sigma is there, and here delta v is there, delta e is there, delta v here, and like that you do some manipulation here and there, then you will get a big equation. S equal to Cc divided by 1 plus E H into log of sigma 2 divided by sigma 1. Right now, this is your S equation, settlement equation. Then this again you can alter it like Cc divided by 1 plus E into H into log of this sigma 2 means what? Sigma 1 addition to something. On a sigma 1, you added something to sigma 1, therefore that becomes sigma 2. Therefore, sigma 1 plus delta sigma divided by sigma 1 is your equation for settlement. This is the equation for settlement. Okay, now very interesting. Now slowly I have entered into settlement chapter. I have entered into settlement chapter. See here, generally when you build a building, this is a building built on the soil, and soil will get settled. If anyone asks you, building is built on the soil. Okay, why soil will get settled? Because soil is compressible. Then compressible means why the soil is compressible? There are four reasons. If the soil is saturated and clay, what is the reason for settlement? Consolidation. Like that, you can give a correct answers in the interviews. Now, the settlement is there, the building is built on the soil, and settlement has happened. Then we have a three different type of settlement. The first settlement is a immediate settlement. Second settlement is a consolidation settlement. Third settlement is a secondary consolidation settlement. Right? Initial settlement means this is immediate settlement. You can call it as a immediate settlement. Immediate settlement. Immediate settlement is always elastic in nature. Very interesting. Elastic in nature. See, in your home you have a chair. In your home you have a chair. On this chair you have a cushion. On this chair you have a cushion. Then you will come and sit on the chair. The immediately when you sit on the chair, then this cushion will sink. That will be considered as a immediate settlement. Or why it is called as the elastic settlement? Because when you stand up, then this cushion will regain its original shape. The cushion will regain its original
Oh,
shape.
shit.
The same way the soil will also regain its original shape. Right? That's why the first settlement is considered it as a immediate settlement or elastic settlement. Okay, we'll write a equation for elastic settlement, that is SI is equal to Q into B into 1 minus mu divided by mu B square. Wait, I forgot it. Anyone know immediate settlement formula? Ah, okay, not this one. Q into B 1 minus mu square divided by E into influence factor. This is your immediate settlement. Q means what? Let us consider this is your ground and you have put one a foundation on this one. Then whatever the load which is acting on the foundation is your Q. Okay, what is this? B? B is the width of the foundation. Width of the foundation. What is this mu? Mu is a Poisson's ratio of soil. Usually it is 0.33 or zero point 0.3 like this. Then what is E? Young's modulus of the soil. Then what is IF? IF is a shape factor. Whether the your foundation is rectangle, circular, or where you want to found a settlement. At a corner you want, or at the middle you want, or at the surface you want. Like that there will be some factors that is called as the influence factor. Then this is your immediate settlement. Okay. After immediate settlement, when you know that the immediate settlement is already set, then after that the consolidation settlement will start. This consolidation settlement is also called as primary compression. Primary compression. Then after this primary compression equation you already know, 1 plus cc dot 1 plus c into the h log of sigma 1 plus delta sigma divided by sigma 1. This you already know. Then after this, if any organic content is there in the soil or organic soil is there, then you will observe yes, that is secondary compression. Secondary compression. The secondary compression equation is not required because most of the soil is organic one. That's why we will not discuss about this secondary compression. Right? This is all about consolidation. Now, look at here. I will introduce you one more term, that is a degree of consolidation. Degree of consolidation. What is the meaning of degree of consolidation? Means how much percent consolidation has happened. Then what is a consolidation? Consolidation is a process of what?
Expelling water.
1 minute. Where I was. I think you are not able to see the rough. Yeah, now. Yeah. Huh. What is the degree of consolidation? Degree of consolidation is a percentage of consolidation. Simply I can call it as a percentage of consolidation. Then what is consolidation? Expulsion of water. Then what is percentage of consolidation? Percentage of expulsion of water. Means if you have a soil like this, then let us consider this much of water is there. If 20% of water is out, 20% of water is out, then I can call it as a degree of consolidation is 20%. 40% of water is out, degree of consolidation 40%. 80% of the water is out, then degree of consolidation is 80%. Now see, very easily we are getting the meaning of degree of consolidation. Degree of consolidation is nothing but percentage of expulsion of water. Right now, how to express this degree of consolidation? Then degree of consolidation can be expressed it like this. Let us consider this is a soil and this is your water and this is your solids. Okay, what do you mean by 100% consolidation? 100% consolidation? 100% consolidation means 100% water expulsion. 100% water expulsion. Is it possible theoretically? Practically? 100% consolidation, is it possible?
No, sir.
No,
No.
100% consolidation is not at all possible. The scientists can achieve 90% of consolidation. Even they are not able to achieve 90% consolidation in the laboratory, but we have a theory. We have a theory. By using that theory, we can determine 90% consolidation. 100% consolidation, we don't have any theory to get it. Right? Then 100% consolidation can be achieved in infinite days. 100% consolidation in infinite days. Now look at here, 100% consolidation is not able to achieve, then in this zone I will keep this amount as a rigid water. No, this cannot be removed. Then whatever that is left here is your freely held water. Freely held water means with the gravity we can remove that water. Right? Now ultimate settlement means what? Ultimate settlement means that all water is expelled out. Right? Ultimate settlement means all water is expelled out. That is your ultimate. Okay. Settlement at any time means what? Settlement at any time may be marked like with a red line. Look at it. Settlement at any time may be marked at this one. Then this is your ST. ST is the settlement at any time and SU is a settlement under that ultimate settlement. Then here by using these two terms I can express degree of consolidation, that is your ST divided by SU. Very interesting. Means you can have delta H at any time divided by that is HV volume. Okay, you can consider it like this or otherwise this one. This is your degree of consolidation. You can multiply 100 so that you will get in a percentage. Now we have got many terms here. Look at here. We have got degree of consolidation. We have got compressibility, coefficient of compressibility, coefficient of compression index, then compressibility. You know, these all terms we got, and we have some concepts like effective stress concept that we have already discussed in the previous class. Effective stress concept. In effective stress concept, we have a pore water pressure, total pressure, you know, total pressure. Considering all of them, our father, who is our father? Terjgi, our father. Terjagi derived one big equation. That equation is about 4 to 5 pages of equation involving differential equations and all. Finally, he concluded one equation that is called as consolidation equation. That is called as what? Consolidation equation. I will write you, I will give you the consolidation equation. You'll remember that. The consolidation equation is dou u by dou t is equal to k divided by mv gamma w into dou square u by dou z square. Don't worry. Okay, this is in higher studies you can understand this one. Okay, this just remember this is a consolidation equation, and here we have one term here. That term is considered as a cv. Cv means coefficient of consolidation. Coefficient of consolidation. Correct? Then what is cv? Cv equal to k divided by mv into gamma w. What is this k? K is a permeability. K is a permeability. In last class, in yesterday's class, I told you about three ways of determining K, right? Laboratory method of determination of K, field method of determination of K, and indirect method of determination of K. That indirect method of determination of K by consolidation test, that is by this equation. This is Cv equal to K into mv by gamma w. Right? This is coefficient of consolidation. This coefficient of consolidation can also be expressed with some factor, some term called as a time factor. We have that time factor TV is equal to CVT divided by D square. This is a very important equation in consolidation, where TV is a time factor, okay, and CV is a coefficient of consolidation, T is a time, and D is a depth of the soil sample. Okay, depth of the soil sample. Here we have two conditions here. Depth of the soil sample may be h or maybe h by 2. This we will be considering h, depth of the soil sample as a h, means d equal to h, when we have a single drainage. Then this will be considered when it is double drainage. Single drainage and double drainage. Then T is the time of consolidation. Time of consolidation. Someone asked, no, sir, how much time it will take consolidation? That is your T. I told you, no, 100 years, no, 20 years, 30 years. That is your T. And TV is a time factor. Time factor, you can get it by some empirical formula. Empirical formula means there are two scientists who studied this TV. Then the first scientist is a Casagrande. Casagrande gave one expression for TV, and another one is a Taylor. Then by using Taylor's method or by using Casagrande method, we can calculate TV, and by knowing TV we can have CV value. Then Taylor, remember this much, Taylor give TV with 50% consolidation. Casagrande gave TV when 90% consolidation. 90% means Casagrande, 50% means Taylor. Taylor used root T concept. You just remember this much. Root T concept, and Casagrande used log T concept. Log T concept. Then after that they will give the Taylor's method or otherwise Casagrande method to determine CV. Then both will give you the value of CV. Right? This is all about consolidation. Right? If you have any doubts, you can ask. Till now, if you have anything, if you want to ask, you can ask. Just I will refresh what we have discussed till now. Okay, we started with a three-phase diagram. Three phases are there. In that one, soil is considered as a compressible material. Why? Because the volume change occurs. Volume change occurs because of four reasons, and first two reasons in compaction. The last reason is for organic soil. The between reason, that is water expulsion, is the primary consolidation. Primary consolidation is our main motto. Then water expulsion is considered as a primary consolidation. Water expulsion happens because of permeability, and this permeability is very high in sand, in low in the clay. Therefore, consolidation process we will not study in sand, we will study in the clay, and consolidation process in clay will be very huge. That will take a lot of time. Then degree of saturation, as the consolidation process increases, degree of saturation will be remain constant. Then after that, we have studied about test. In the test, you just remember, we are going to increase the load, doubling the load, and we are studying getting the readings by doubling the time. Then first few days we will be doing loading, and after few days we will be doing unloading. Unloading will be 1/4 of the earlier load, and after that few days we will be doing reloading. Then this test completes. Then loading will give you compression, unloading will give you expansion, reloading will give you recompression. This is given an example of constructing a building. Then after that we have studied a type of consolidation: under consolidation, normal consolidation, over consolidation. Over consolidation is considered to be a best one. Then after that, for a particular day we have started studying the settlement. Then settlement means delta H. We have drawn a graph for E and load. E and load, where we have introduced one term that is called as compression, com, volume compress, sorry, coefficient of compressibility. Right? Then after that, this is not possible to fit in the normal graph. Therefore, we introduce semi-log graph. In semi-log graph, the slope is considered as a compression index. Then after that, we went to strength of material. From there, we borrowed one concept that is called as compressibility. Compressibility is equal to inverse of bulk modulus. Then bulk modulus equation we know, therefore compressibility equation we derived. In the compressibility equation, we have got a delta H. Delta H means settlement, therefore we have got settlement equation. This settlement equation is studied in the consolidation, therefore this is called as a consolidation settlement. Then what about other settlement? We have three other type of settlement, that is immediate settlement, consolidation settlement, and secondary consolidation settlement. Immediate settlement is considered as elastic settlement. Why? Because it will regain its original size of the soil. Therefore, it's considered as the elastic settlement. I think you might be knowing this one. That is, this mu and E. These two are considered as elastic constants. These two are considered as elastic constant. Do you know other two elastic constants? Check. Who can answer other two elastic constants? Who is very serious in studies? They can answer it. First day we discussed four elastic constants are there. ಓದ್ರು ಮರಾಯ ಓದಂಗಿಲ್ಲ ಏನಿಲ್ಲ ಬರೇ ಕ್ಲಾಸ್ ಕೇಳೋದು ರೆಕಾರ್ಡೆಡ್ ವಿಡಿಯೋ ಕಳಿಸ್ತಾರ ಆಮೇಲೆ ನೋಡೋಣ. See, 2 months of SSC preparation definitely will give you a result. Definitely will give you a result if you study 16 hours a day. Even a small running sports person or cricketer, they will work for 16 hours. If you run for half an hour, your legs will be paining, no? Then those running practitioner, that sportsman, they will run for 16 hours. In the same thing, 16 hours you have to study. The other two elastic constants are what is
G and K.
G and K. Okay, that is bulk modulus and shear modulus. Done. After that, we introduce you one more term, that is called the degree of consolidation. Degree of consolidation. There, it is nothing but a percentage of removal of water, percentage of expulsion of water. Then 100% is not possible, 90% is possible. Then we gave equation for this one, degree of consolidation. Then after that, by using these all terms, Terjgi derived given theory, and that theory gives you this big equation where CV is the coefficient of consolidation. Coefficient of consolidation, by that equation you can determine indirect permeability also. Then equation for time factor. By using this time factor we can determine CV. Then we have got two theories, Taylor's theory and Casagrande theory. Taylor used T50 concept, Casagrande gave T90 concept. Taylor used root T concept, Casagrande gave log T concept. End of the chapter. Rita, do you have any doubts? If you don't have any doubts, then we'll take a small break. Now it is 9:53. We'll assemble exactly at 10 o'clock. Okay? Any doubts?
Okay.
Okay. We'll start the first question. Consolidation time for soils. Hmm. Consolidation time of soils increases with increasing compressibility.
So option A.
Right answer. But read the second one. Decreases with increasing permeability. Right answer. Is independent of stress change. Right answer. Therefore, D is the correct answer.
Yes.
Next, pick up the incorrect statement. This is compaction. We'll discuss later. This will discuss later. Hmm. 2.4. For routine consolidation test in laboratory, the thickness of the specimen is by heart 20 mm. Hmm. If voids of soil mass are full of air only, the soil dry soil. The rate of consolidation
So B.
B. How? Any correct explanation? Reason? Because see, a temperature is there means it is something related to viscosity. Correct? Increase in temperature increased. Viscosity, what happens to viscosity of water? Temperature increases viscosity.
Decreases, sir.
Viscosity decreases means the water become thin. Water become thin means water escapes very fast. Very fast escape means increase in consolidation. Therefore, rate of consolidation increases with increase in temperature. B option. Unconfined compression strength test is, this is shear strength chapter. Undrained test it is. Which is the correct answer?
First one, sir.
Correct answer. Then unit of coefficient of consolidation is. Can you derive a unit of coefficient of consolidation? Use this equation only. Use this equation and get a unit of consolidation. But TV means no unit. TV don't have any unit. Then this is meter square by second. Is there any answer? Centimeter square per second is the correct answer. Optimum moisture content is obtained from. If you know, you can answer it. Standard property test. Effective size of the particle of the soil is denoted as D10. Already discussed. Which of the following soil has a uniformity coefficient more than 10? More than 10 sand. Well graded. Correct. Well graded. Correct. Then uniformity coefficient of filter sand is represented by filter sand. This comes in water supply filtration chapter. ಅಲ್ಲಿಂದ ತೆಗೆದಿಲ್ಲಕ್ಕೆ ನಾವು write down D option.
So D50 by D10.
Correct. No, not water supply. Uniformity coefficient it is said. Just I confused with the filter sand. Uniformity coefficient is defined as D. 60 by 10. The coefficient of compressibility of a soil is the ratio of compressibility. See here we have many terms. No, you may get confusion in exam. Coefficient of compressibility, volume compressibility, coefficient of consolidation, degree of consolidation. Now this answer. See here. Coefficient of compressibility, not volume compressibility. That is a C, that is 1 by K. K means what? Stress by strain. Then what about this? C is equal to strain by stress. Which option? B option. Okay now. Which of the following shows the time factor for 50% degree of consolidation? It is approximately asked and you have to remember this one. A. A is the correct answer. The correct answer is, because they are asking approximately, the correct answer is 0.187. 0.187. Okay. Next. This is compaction. We'll solve it later. This will solve it later. Which of the following roller compaction it is? Compaction. You can answer this one. 20th. This 20th question, no need to answer it by using consolidation chapter. You can answer it by first chapter also, three-phase dive.
V1 by V2 is equal to 1 plus E1 by 1 plus E2, sir. Our formula use.
V1 by V2 equal to 1 plus E1 by 1 plus E2. Okay, right. You can use this one. The clay deposit has a thickness of 10 centimeter. Whites ratio 0.5. Undergoes a settlement. Now its final whites ratio is this one. The thickness means here you know E1 and E2. Correct? What about V1 and V2? We don't know. Therefore, what we'll do, divided by area, this become H1 by H2. This become H1 by H2 equal to 1 plus E1 by 1 plus E2. Okay. See, this one, what you answered, you might be remember the first chapter concept. Otherwise, also you can remember this one. Delta
Yes,
S
sir.
equal to 1 plus E into MV, something given, no? That also you can remember. Here also 1 plus E is there.
Yes.
Then two conditions you can write and you will arrive with the same condition. Now
Yes,
answer.
sir.
Answer. 2. 2 is the correct answer. Next. Which of the following represents the percentage limit of porosity of the compacted sand? Hmm, not required, we'll discuss later. Pick up the correct statement of the following continuous grading necessary. We'll discuss later. You can answer this one. Standard penetration test, SPT, hydrometer, Proctor test, vein test. This is a complete geotechnical, but still you can answer. Standard penetration test, bearing capacity. Hydrometer test, grain size analysis. Proctor test, compaction. Vein shear strength,
Compaction.
shear strength. This we can discuss later. Stress distribution later. Piston spring. Piston and spring analogy method was determined by Terji for which of the following process? Actually, this concept, piston and spring concept, is used to explain effective stress concept. But out of these four options, we don't have effective stress. Therefore, consolidation I can consider. Soil particle gradation, permeability, compaction, consolidation I can consider. Other than this one, this concept can be used for effective stress explanation also. Effective stress concept explanation also. Next. If a flow velocity field is given by this, then flow is three-dimensional. Flow is physically possible and rotational. This is fluid mechanics. Fluid kinematics, we'll discuss later. Consolidation test, when the load is changed from 50 to 100, then the White's ratio changed from 0.8 to 0.6. The coefficient of compressibility will be coefficient of compressibility formula. AV equal to delta E divided by delta sigma. Substitute. 0.8 minus 0.4 is 0.2 divided by 100 minus 50 is 50. The answer is 4. This we will discuss later. Rigid footing on cohesive soil. The contact pressure distribution is discussed later. Which type of roller? Discussed later. Saturated soil compaction index. Compression in you can solve this one. CC it is. Compression index. The White's ratio at a stress of 12 is this much, and at a and its permeability is this much. What is the change in White's ratio if stress increased to this much? Take log 10 equal to this, and they have given, means calculator is not given, no? That's why the log 10 value is given. Which equation? Cc equal to delta E divided by log of sigma 2 by sigma 1. What they want? What is the change in White's ratio? Means they want delta E. Delta E. Cc is given 0.28 into log of initial load is 12 and 21. Bigger is 21. Therefore, I'll write 21 first divided by 21.6 divided by 12. I think this might be log 1.8. This is log 1.8 means you have got 0.28 into 0.255. This answer. This answer is change in White's ratio. What is the change in White's ratio? Okay. This answer will come. Which one answer? 32.0715. Now, normally consolidated clay layer settled by 20 mm when the effective stress was increased from this to this. What will be the settlement when the effective stress is increased to 50 to 100? Interesting. See here they are talking about what? Consolidation settlement. Normal consolidated clay layer settled by 20 mm when effective stress was increased from this to this. Then what will be the settlement when the effective stress increased from 50 to 100? Okay, done. Look at it. First settlement, we will write a equation. What is the settlement? First 20 centimeters of settlement. That is equal to Cc divided by 1 plus E. H log sigma 1 by sigma 2 is given 50 by 100. 50 by 20. What is H? You don't know. H is not given. Therefore, what we'll do, interestingly, we will make this entire thing as one parameter. Okay, na? This entire thing is one parameter. Now, can you find this black parameter? That black parameter equal to 20 divided by log of 50 by 20 means 5. If you don't have a calci, you can Keep it as it is. We'll solve it like this. 20 equal to Cc divided by 1 plus E into H as a one parameter into log of 50 by 20 is one equation. Another equation, delta H equal to, or settlement equal to Cc divided by 1 plus E into H into log of 50 by 100, 100 by 50, 100 by 50. Here 20, this entire thing is there, this we will consider it as a one thing. Then here Cc by 1 plus E means that box is equal to 20 divided by log of 50 by 20. Okay, now then in the place of box I will substitute that delta H equal to 20 divided by log of 50 by 20 into log of 100 by 50. Okay, this is just 20 into log of 100 by 50 is 2, log 2 divided by log 50 by 20 is 2.5. This we got. Can anyone simplify further? Or you have to guess answer.
15.12.
Uh, this simplification is possible further, or we have to guess the answer. Then 20 is the answer. Next, degree of compaction of the soil is a characteristics characterized by. We'll discuss later. Degree of compaction, we'll answer it now only. Degree of compaction of a soil is characterized by compaction. They are discussing consistency, compressibility, dry density, saturated unit weight, dry density. Select the correct options. Interesting. The soil is termed as normally consolidated if the present effective overburden pressure is less than the maximum to which the soil was ever been subjected to its in past. Correct answer? No. According to this statement, normal consolidation, what they are saying, present pressure is equal to, is less than, present pressure is less than the maximum to which the soil has ever happened. ಅಂದ್ರೆ Taj Mahal example it is, na? Past pressure. Taj Mahal example. Taj Mahal example is normal consolidation. No, this is wrong. Therefore, S1 is wrong. The larger the value of coefficient of consolidation, CV, shorter it takes the full consolidation to occur. Okay. Here they are discussing with the time. Shorter it takes the full consolidation to occur means is the event. Event means time. CV is equal to formula.
Yes.
That formula was there, no? TV. CV.
Tau v into T divided by D square.
No. TV into T divided by D square. Larger the value of coefficient of consolidation, the shorter it takes for full consolidation to occur. No, we'll not use this equation. We'll use another
It's
equation.
wrong, sir.
K divided by mv into gamma w will use. We'll take the help of K, then we'll decide. Coefficient of consolidation is increased, then permeability is more. Permeability is more means shorter shorter it takes to occur. Correct answer. Therefore, this is the correct one. Therefore, S1 is false. Yeah. And S2 is true. C option is correct. Return. Do you have any further doubts? Are we following our timetable? Just we'll go through once. Okay. See, today's date is 18th, 17th. Yes, we are following the timetable. Consolidation and settlement is over. Okay, these all are over. Tomorrow, compaction and shear strength we have to discuss. Right? Any doubts, particular, anything we want to discuss? Give me a feedback whether the classes are going properly or not. But before accepting feedback, I have to tell you something that in less time I have to cover more syllabus. That's why if you are saying that sir your class is very fast, then excuse, you have to give excuse for that because it has to be very fast. Other than that, if you want, you can give any suggestions to improve. Okay. If no suggestions, then we'll end the meeting. Thank you.